A narwhal's tusk is one of the most intriguing features in the animal kingdom, often misunderstood as a horn or a weapon. In reality, it is an elongated tooth, specifically a canine tooth, that spirals outward from the narwhal's upper jaw. This remarkable structure, primarily found in male narwhals, can grow up to 8 to 10 feet, 2.5 to 3 meters long, and is packed with up to 10 million nerve endings, making it a highly sensitive organ. Below, I'll explain in detail the structure of the tusk, its sensory capabilities, and its potential role in sensing environmental changes. Structure of the narwhal's tusk anatomical basis. The narwhal's tusk is a modified left canine tooth that protrudes through the upper lip, typically in a left-handed spiral. In rare cases, females may develop a tusk, and some narwhals even have 2 tusks if both canines are up. Unlike typical teeth, the tusk lacks enamel on its outer surface. Instead, it is covered by a layer of cementum, a softer, porous material that encases the dentin core. Dentin and nerve endings. The core of the tusk is made of dentin, a hard but porous tissue that contains millions of tiny tubules. These tubules extend from the pulp cavity at the tusk's base to its outer surface, connecting to approximately 10 million nerve endings. This high density of nerves makes the tusk extraordinarily sensitive compared to human teeth, which have far fewer nerve endings. Spiral pattern and growth. The tusk grows continuously throughout the narwhal's life, with the spiral pattern thought to provide structural strength and flexibility. The tusk's surface is marked by ridges and grooves, which may increase its surface area for sensory purposes, sensory capabilities. The tusk's millions of nerve endings are connected to the narwhal's nervous system through the dentin tubules, which are filled with fluid and sensory nerve fibers. This structure allows the tusk to function as a sensory organ, capable of detecting subtle changes in the narwhal's environment. Research, particularly a 2014 study led by Dr. Martin Nguyen, a dentist and narwhal researcher, revealed the following sensory capabilities. Pressure sensitivity. The tusk can detect changes in water pressure, which may help narwhals navigate their Arctic environment, where ice cover and water currents constantly shift. Temperature detection. The nerve endings are sensitive to temperature variations, which could allow narwhals to sense changes in water temperature, potentially aiding in locating open water or prey in icy conditions. Salinity and chemical cues. Experiments showed that the tusk responds to changes in water salinity. When exposed to high salinity water, narwhal heart rates increase, suggesting the tusk can detect chemical gradients in the ocean, possibly to locate food or avoid unfavorable conditions. Mechanical sensitivity. The tusk's porous surface and nerve-filled tubules can sense physical contact or vibrations, potentially helping narwhals detect nearby objects or other animals. Potential uses in sensing environmental changes. The narwhal's Arctic habitat is dynamic, with shifting sea ice, fluctuating temperatures, and varying salinity levels. The tusk's sensory capabilities likely play a role in helping narwhals adapt to these conditions. Navigation and migration. Narwhals migrate seasonally through Arctic waters, often navigating through ice-covered regions. The tusk's ability to sense pressure and temperature changes may help them find breathing holes, polynyas, or thin ice, critical for their survival as air-breathing mammals. Foraging. The tusk could assist in locating prey such as fish, squid, or shrimp by detecting chemical cues or salinity gradients associated with productive feeding areas. For example, areas where freshwater meets saltwater often attract prey, and the tusk's sensitivity to salinity could guide narwhals to these zones. Social and reproductive functions. The tusk may also serve social purposes, as its sensitivity could allow males to detect pheromones or other chemical signals from females or rivals. The tusk's prominence in males suggests it may play a role in mate attraction or dominance displays. Similar to antlers in deer, environmental monitoring. The tusk's ability to sense subtle environmental changes could help narwhals respond to shifts in their ecosystem, such as melting ice or changing ocean currents due to climate change. This makes the tusk a potential tool for monitoring the health of their Arctic environment. Additional functions and theories. While the sensory role is well supported, other theories about the tusk's function exist. Weapon or tool? Historically, the tusk was thought to be a weapon for fighting or breaking ice. While narwhals have been observed tusking, rubbing tusks with others, this behavior is more likely social than aggressive. The tusk's sensitivity makes it unlikely to be used as a weapon, as it could cause pain. Hydrodynamic advantage. The spiral shape may reduce water resistance or aid in maneuvering, though this is speculative and less supported than the sensory hypothesis. Evolutionary artifact. Some suggest that the tusk is a vestigial structure with no primary function, but its high nerve density and energy cost to grow argue against this our scientific evidence and research. The sensory hypothesis gained traction through Duchenwia's work, which combined anatomical studies, field observations, and experiments with live narwhals. By dissecting tusks, researchers confirmed the presence of nerve-filled tubules. In controlled tests, narwhals showed physiological responses, e.g., increased heart rate, when their tusks were exposed to different salinity levels, supporting the idea that the tusk is a dynamic sensory organ. Indigenous knowledge from Inuit communities who have long observed narwhals also aligns with the sensory role, as they describe the tusk as a tool for feeling the environment. Challenges and unanswered questions. Why only males? The Sianda tusk's prevalence in males suggests a possible sexual selection role, but why some females have tusks and others don't remains unclear. Exact mechanisms. While we know the tusk detects environmental changes, the precise neural pathways and how narwhals process this sensory input are not fully understood. Climate change. Impact as Arctic ecosystems change, how the tusk's sensory role adapts to new conditions is an open question, especially given the narwhal's vulnerability to habitat loss.